Cool. All right, mechanics kids, let's talk about what we've covered so far and what we're looking at today. So we've covered all of the speed and motion off of our checklist in our last lesson. So yeah, the question itself covered it. Because remember, we went through one of those exam questions. And with that exam question, we did all of the ones that were here. So all those are ticked off. All right. We're going to be looking actually at the bottom. We're going to do things a little bit out of order. And we are focusing on the last three checkpoints. So we're thinking about gravitational potential energy, kinetic energy, the conversion between the two. The reason why I wanted to go to this one is because since we talked about speed and motion in our previous lesson, we can now use some of that speed information for the energy, so that V value. All right. Let's unpack this question as a means to kind of learn how to use these equations. So we are talking about Lindley, who looks down the stairwell and her helmet falls off. The helmet falls between the stairs without touching them. So it's like straight down, no interference. She estimates that the helmet would hit the ground at 20 meters per second. Whenever they give me a value, I like to underline it to make sure I know what I'm doing, know what I'm using. And I can see by the units they've given me, it's meters per second. So that tells me that that is a velocity. So I'm just going to note that with the V so I can think about how I'm going to be using that information. Are we okay with that so far? Okay. Next one is that they're talking about using the conservation of energy, assuming no other external factors, calculate the height from which the helmet fell. So height is going to be my H. And that is going to be my question mark because they're asking me to calculate it. So that's my unknown. Are we good so far? All right. They've given me the mass of the helmet, which is 1.5 kgs. That's also useful. That's M. And then they give me some bullet points. Really use these bullet points because they help structure your answer. And it basically acts like a checklist to make sure you have everything. So they want us to calculate kinetic energy. Kinetic energy is your EK of the helmet just before it hits the ground, and describe which form of energy this kinetic energy has transformed. Are we good so far? Energy. Now, for physics, I like to organize things with my knowns, my unknowns, and my equations so I can think about the order of which I'm doing things in. This is actually a technique I learned when I was in high school, and I thought it was really helpful. So we list out our knowns, we list out our unknown, and we list out our equation. So first off, I know that V is equal to 20 meters per second. I know that M is equal to 1.5 kgs. The unknown that I'm trying to solve for is H. And now let's look at our equation sheet to think about what equations I might want to use. In this example, you're going to be using two equations. So this is known as a two-step problem. I am looking for equations that could have the energy value, the H value, the V, and the M. So when I look here, there are two equations that talk about energy. There is the kinetic energy equation, which is half the mass times velocity squared. There's also the gravitational potential energy, which is mass, grams, and height. So we can see here from these two equations, I have what I need in order to solve. So I'm going to copy those equations down. So EK equals 1/2 mv squared, and EP equals mg times h. So that's gravitational potential energy. What they say is, in this question, they say assume conservation of energy. So what that means is whatever value you get for the kinetic energy is the same as whatever they get for the potential energy. I assume those two are the same.
Where does it say?
It says that using conservation of energy. So that using conservation of energy tells me assume EK equals EP.
Oh.
Right, keep going?
Yep.
Okay, so let's use this first equation here to find my EK, because I have the mass value and I have the velocity value. So I would go EK is equal to 1/2 times 1.5 times 20 meters, sorry, times 20, and then times 20 again, because that is squared. That's what squared means. Times the 20 twice. All right, let's see what that is. All right, taking out my calculator. Make sure you guys have a calculator for the exam. They're not going to let you use your phones. So 1.5 times 20 times 20. And then you can divide it by 2, or you can times it by 0.5, because 0.5 is the same as saying 300. So my kinetic energy equals 300 joules. That's my unit for energy. J, joules. Yeah, just J. Are we okay so far? All right, since I'm assuming that the energy that's kinetic is the same as my gravitational potential energy, I now have the EP value. So EP, that all of it equals 300. I have the mass. I have gravity. Gravity is one of my given constants. It is 10. And then height would be my unknown. Okay, gravity is given to me. G. G equals 10.
Oh, okay.
So if I was to plug that in, I would have EP equals M times G times H. Potential energy is 300. My mass is 1.5. My gravity is 10. My height is my unknown. So it'd just be 300 equals, I think that's 15, isn't it? 1.5 times 10, 15 times H, divide by 8, or divide by 15, and I get my H.
Will that be from condition 5?
20. So H equals 20 meters. That's the height that the helmet was dropped from. Yeah. Next page.
Yep. Let's find a question. Curious.
Okay. Next. Oh, that's not the right question. Where's the other question? Is it on the back? Yes. Okay. Next question here is an explain question. Unfortunately, every so often you do get this with physics. So just kind of keep in mind you can't just rely on the math alone. So they want us to explain why the helmet would not reach 20 meters per second. So in theory, that's what it's supposed to be, but it may not be the case, and we need to think about why is that the case. We have to remember that this is not happening in a vacuum. There is going to be air resistance. So that air resistance is the big factor. What happens is when this helmet is falling, we have gravitational potential energy. Oopsie. Get that to focus again. We have gravitational potential energy, and that's going to get converted into kinetic energy. So that way it's moving. So that's why when I drop things, things start moving. That conversion of energy. Now, part of the problem is that not all of the energy gets converted to kinetic energy. Some of that energy is going to get converted into heat energy. And that heat energy is the result of air resistance. So what happens is when things are falling, there's air resistance, and that's actually going to slightly heat up the helmet.
Oh, that's why.
Yeah, heat energy. So that's from the air resistance. Yeah. So since I'm losing some of my heat energy, or sorry, some of the energy to heat, my kinetic energy is going to reach the 20 meters per second as predicted.
Does that say from or for?
From. Sorry, from. My handwriting is trying to write fast. I'll give you guys the marking schedule so you guys can see how the points broke down. Ignore 2A because we haven't done that question. We were just working on B and C today. And I'll quickly talk about it. I'm going to give you guys the marking schedule so you guys can start learning how to read it. All right. So, breakdown of the points. The first question with the calculation, the excellence was basically getting the final answer that I got, making sure you show your work and your units. If you make a mistake, they are then able to give you some points elsewhere. Be mindful that I want you guys to show your work, because if you just write down your final answer and no working and your final answer is wrong, then it's automatically zero, nothing, no points. If you show me the working, then they might be able to give you some points. So for example, the merit is correct method, but a mistake in the working, allow for follow-on errors. So that just basically means maybe you copy down the wrong number, or you just did something silly, like you forgot to square something, but everything else is correct. They then would go, okay, we'll give you a merit point still. The other option is the first two steps are correct. Maybe you did something funky with the last step. The achieved was if you calculated the kinetic energy correctly, or if you implied that you knew that kinetic and gravitational potential were the same number. On that question C, stating that you knew there was air resistance or they lost kinetic energy, the merit is actually now explaining the why, because of air resistance. And the excellence is having all three layers into your answer. So explaining what air resistance is, how that results in kinetic energy loss, and then what does that mean for the final speed. Okay? That's it for this question.